which is Nyquist plot and Bode plot. Okay, so Nyquist plot is also called as a polar plot. So what I am thinking here is to share this slide on the Google Classroom so that everybody can have it, because I am seeing only 10 students have come to the class. So um, I will give you an introduction and I will share this whole PowerPoint on the Google Classroom so that everybody can see this part. This is unit 5th. So basically this is a frequency domain analysis. Till unit 4th we have done the time domain analysis. So the difference between time and frequency is that frequency domain we are having frequency, whatever response, time response we are plotting, we will plot it as a function of frequency. And in time domain analysis, the response is plotted against time axis. Okay, so Nyquist plots were invented by Nyquist, who worked at Bell Laboratories, the premier technical organization of US. Nyquist plots are also a way of showing the frequency response of linear systems. There are several ways of displaying frequency response data, including Bode plot and Nyquist plot. Bode plot uses the frequency as the horizontal axis and two separate plots to display the amplitude and phase of the frequency response. As you know that the frequency is basically consists of two parts. One is amplitude and the other one is frequency. So if we plot the amplitude versus frequency, then it is amplitude plot. If we plot the phase versus frequency, then it is called the phase plot, and both of them constitute the Nyquist plot or polar plot. Okay, so Nyquist plots display the both amplitude and phase angle on a single plot using frequency as a parameter in the plot. Nyquist plot has properties that allow you to see whether a system is stable or unstable. A Nyquist plot is a polar plot of frequency response of a function of a linear system. That means Nyquist plot is a plot of transfer function Gs with S equal to j omega. That means you want to plot Gj omega. Gj omega is a complex number of any angular frequency omega. So the plot is a plot of complex numbers. The complex number Gj omega depends upon frequency. So frequency will be a parameter if you plot the imaginary part of Gj omega against real part of Gj omega. So the steps to sketch the polar plot of frequency response for the entire range of frequency omega, that is from 0 to infinity, there are 4 key points that usually need to be known. The start of plot where omega is 0 and the end of plot is where omega is infinity. Where the plot crosses the real axis is the point where imaginary part of Gj omega is 0, and where the plot crosses the imaginary axis is where real part of Gj omega is 0. So based on this, we plot the polar plot. Suppose the first order system Gs is given by 1 by S. So representing Gs in frequency response, so S becomes equal to S equal to j omega. So replace S by j omega. So Gj omega is 1 upon j omega. And normally we don't want to keep j in the denominator side. So we multiply numerator and denominator by j. So it is basically j upon j square omega. J square is minus 1. So minus j upon omega. Okay. So the magnitude of Gj omega is obtained by, if you take the magnitude, then it is 1 by omega, and the phase of Gj omega is minus 90, as it is minus j here, right? So if you plot the Bode plot, basically you plot as a function of frequency, and you take as in dB terms. So 20 dB, 40 dB, 60 dB, etc. on the magnitude side, and this is the phase plot. So it is 0, 90, 180. So it is, since it is minus 90, so it is basically minus 90 for every frequency, and it is 1 by omega. So it is a inverse linear function. Okay. So this is the Bode plot. This is the polar plot, because starts from j equal to, where omega equal to 1, it is minus j. Where omega equal to infinity, it's terminates at this point. Okay. So you can also find out the polar plot of 1 upon s, 1 plus st. So replace s by j omega. So it is 1 upon j omega t. So mod of j omega t is 1 upon under root 1 plus square, omega square t square, and angle of gg omega is minus tan inverse omega d. Okay, so the start point of the polar plot is where omega equal to 0. So mod of gg omega is 1 upon under root 1 plus 0, so it is 1. And angle is tan inverse 0 upon 1 is 0. So, and where at the end of the plot is where omega equal to infinity. So 1 upon under root 1 plus infinity is 0, and phi is tan inverse minus infinity is minus 90. And the midpoint of plot is where omega is equal to 1 by t. So it is basically 1 upon under root 1 plus 1. So it is 1 upon under root 2, and phase is minus tan inverse minus by 1 by 1. So it is minus 45. So you plot the polar plot and you get a figure like this. Okay, so you draw this table and draw this diagram. Polar plot for this type of system, and if you do that you'll get a plot like this. You can draw this also. you solve such type of problems. And then you find out the plot where the plot crosses the imaginary axis, and you draw the Nyquist. You draw a table like this and draw the Nyquist diagram like this. You can note down. What I'm doing, I'm uploading this on the Google Classroom so that everybody can have this unit file. Okay. I have to remove this from here. I'm stopping the presentation for a while.